Hi, this is a Figment tutorial about expressions. In Figment, we recently launched this expression language that you can use in order to control parameters dynamically. So I want to show a little bit about how expressions work and then immediately go into OSC, which is how we can connect expressions from Figment to other software. So let's open Figment here. And while I'm here, I also have this expression page open. As you can see, there's a bunch of information and documentation, and there's also a list of built-in functions that you should understand. And these are mathematical functions or randomness or whatever. So what we're going to do is really simple. We're just going to have our default network here. We're loading a movie, resizing them, and then we're removing these parts. And I'm going to replace that with a transform. So double click, create a transform node, connect it. And now what I can do, I can stack it if I want to. It's not really the point of this, but what I can do here with all of these parameters is add expressions to them. And so the way that expressions work is they basically replace this value with something dynamic that comes in. So for example, the translate would be a value that moves this from left to right. Translate here would move this. Scale, scales it up. Rotate, rotates it like this. So which expressions can we use? Well, first off, how do we use expressions? Maybe that's the first thing to answer. So here you see these three dots. When we click them, there's two options that we can do. We can refer to the default value. So for example, if we want to reset these, we can do that. But here as well, we can do edit expression. And so now this field turns green, and that allows us to type in something that's an expression. And so a typical expression that we might use is $ and then frame in capitals. And this will link the current frame to the rotation of this transform. Now, I was very careful to do this specifically for rotation, because rotation after 360 degrees, it just continues, it keeps going. If I want to do this with different parameters, for example, translate, you'll immediately see that we get into trouble. The thing is no longer there, and that's because the frame keeps increasing. So now it's at 1,000 frames, but the value of translate can only be between -2 and 2. So this value is already way too big. In that moment, we have to find ways to manipulate our frame or find ways to do things with it. A typical thing that we can do with it is here use an ampersand and then say 2, for example, and that will get the frame and then throw it back to 2. Now this doesn't really work for frame. It works better if we use time, for example. You can see it sort of rolls off the screen now. Time is the same as frame, except that this is 60 times slower because this is once per second is the increase of time. So this ampersand 2, what this means is it takes the modulo of the value. It's basically the remainder of the division. So this value will never be higher than 2. That's the main thing that happens. If we want this time to be smaller, we could do like -2 and whatever. But there's a different expression for this that I can show immediately, which is pingPong. And pingPong gives us a minimum and maximum value, and it's going to oscillate between the two. So let's try that. We can write pingPong. We give it a minimum value, -2, and a maximum value 2. And now you can sort of see that it moves from one to the other. Now it goes pretty quickly, so pingPong takes another value here. That's why this documentation is so useful. It has a period, and the period is how fast does it go. So the period is in seconds. So if we make this into 5, for example, this will go from -2 to 2 in 5 seconds. And then it also takes a type, which is now by default set to smooth, which is like a sine wave, gradually goes from one to the other. There's also linear, so we can type linear here. Don't forget the double quotes around it. And then we'll sort of go from one and then bounce, as you can see, to the other. And then the last one which we have is step. And what step will do is it will stay on this one value and then go to the other value. And you see these are really like almost off screen, so I make it a bit smaller. Then you can see, so it sticks here, and then it sticks there, and then it jumps back to the first one again. So that's a very useful expression that we can use. There's a bunch of other ones that you can see here. Random, for example, we can show as well. So if you use random here, it's sort of, you have this glitchy effect because every frame it gets a different value between 0 and 1. And of course, if we want to increase that value, we can do multiply by 2, for example, to get a more glitchy effect. Let's get that back. I want to talk specifically about this last one, which is the OSC. So OSC is the Open Sound Control, and it connects multiple applications together. These applications can run on the same computer, but they can also run on different machines, and it allows applications to talk to each other. This is an open standard, so a lot of applications talk OSC. There's MaxMSP, there's Touch OSC on your iPhone, and the one that we're using today is SonicPy. SonicPy is a live coding environment that allows you to connect all kinds of inputs, send all kinds of outputs, and it's basically like a little live coding for a sound. Now, the nice thing about SonicPy is it's fully open source, it's free, we can use it, and it's very user-friendly. So that's what we're going to connect to. So I'll first show a little bit of SonicPy. This is not a SonicPy demo. I actually learned it from another YouTuber. I'll link to him in the comments. But I will just show the main environment and then you can have a look. So this is what SonicPy looks like. There's a run button and a stop button. If we press run, it runs the file that we're running here. And yeah, we can record the sound and things like that. And on the scope, we can actually see what's going on. So I'm going to make a really simple one that's just randomly picking notes from a scale. So to do that, I'm first going to set a BPM, so beats per minute, and I'll make a scale. So I'll get some notes, like an E4 from the Iwato scale. And there's a bunch of scales that we can choose here. I think if we do it like this, you can actually see a bunch of these scales. Yeah, here's like a whole list of all the scales that are available. So feel free to experiment with that. And now let's print these notes out. And now if we press run or Command R, then we'll actually see which notes are in this scale. So 64, 65, 69, 78. So these are actually note values that we want to use. They're not in frequencies, but these are the values that we want to use. And these are important because in a minute we will send these note values to Figment. So we have to know what the minimum and maximum values are. So let's actually do something with these notes. So what we can do is we can say here, let's do something 8 times. We choose a note. So we say notes.choose. That's going to pick a note from that scene. And then we can say play note with a release time of 0.2. And then we sleep a little bit and then we end. So let's run that. Again, Command R to run this. So this is one pattern. If we do it again. So we always keep hearing this same pattern, and it would be nice if this would be repeating all the time. So around this, we can do live loop. We can give it a name, and then this gets indented, and then we can do this. Now, this will play immediately after the next one. So it's just 8 times, and then immediately the next one, so we can sleep after this for a bit longer. All right, cool. So this is our main pattern, but now how do we connect it to Figment? So in Figment, one of the things that we can do is we can go here to File, Project Settings, and we can enable OSC. So at that point, Figment is listening to OSC events on port 8000. And you can see this happening here because here in Figment, you actually get this little widget here that indicates how many signals it gets in. Now, currently this is empty, so it's just this line indicating, okay, I'm on, but I don't receive anything. So we have to send signals from SonicPy to Figment. And the way that we do that is we say use OSC. We can send where the OSC data goes, but because it's the same computer, we can call this localhost, basically meaning our computer. And then the ports, this is the same port as we see here in Figment, so we connect these two together. And now we have to say when do we send nodes, or when do we send whatever data that we want. In this case, we want to send the actual note, the note value. So we're going to do this after we've played it. Here we're going to say OSC. OSC requires an address, so where do we send the data to? We can call this whatever we want. We can call this hamburger if we want, as long as we use the same name in Figment. And then, so this is the address. And then the actual value is also node. So remember, these are one of these values that come here, like 65, 64, 74, and so forth. And again, the range is from 64 to 76 specifically for this scale. So now if we run, what we should see is it's playing the music, but also in the background, you see in Figment that you get this data here coming in. So this is specifically what we are looking for, and this is cool. But of course, Figment doesn't do anything with it yet because none of the parameters actually do this. So let's try it here. Let's edit this expression. Well, let's make it ourselves a bit easier. Let's do it for the rotate value first. So we're going to say OSC. So we know that it's called /node. And then OSC parameter requires a second parameter that we can leave empty if we want, which is a default parameter. Like if there's nothing coming in, there's nothing connected, which value should I use? And remember, we're getting node values again from 64 to 76. So having a default like 64 would make sense here. And then now this is locked to this rotation. But now if in Sonic Pi we press play, we run, we'd actually see that this moves around, right? Because every time a node comes in, we actually see that this rotation value is going to change. It would be cool if we actually see a full rotation, because now this is just partly rotating. And that's where the map function comes in. And this is also an essential function that's going to map an input value to an output value. So basically an input range, or we call it domain, which is what the size of the values are that are coming in. And then the output is the range of values that we want to get out of there. So in our case, the input minimum and maximum are from 64 to 76, that's the scale. And the output would be from 0 to 360 degrees, for example. So going back to Figment, let's type that in. The first value is going to be our the OSC itself. So we write a map around this. So we say map. This is the value that's coming in. The input range is from 64 to 76. And the output range is from 0 to 360. All right. And now if we press run, we see that we get much more variation in the rotation. Of course, we can do this with any parameter we like, and then also we can combine it with other parameters as well. So for this final thing, what I'm going to do is a really simple script. I'm just going to use my webcam here. Hey, that's me again. I'm going to make a transform node. I'm going to scale this up. So I just want to see my eye. This is actually flipped, so I'm going to use a -4. And then I'm going to use a threshold. And the threshold will take out just a small part of my eye, because I just want this. And then I'm going to use a border because I just want the eye itself. And so if I increase the border size, I can show you if it's red, for example. If I increase the border size, it basically goes around the eye. Now, I don't want the border to be red. I actually want it to be transparent. So I'm going to set this alpha value to 0. And now what I can do is I can use this node called trail. And trail will basically leave in this value and work with that. There's one more node that I want to use, which is this transform node that I did before, but I'm going to make a new one. So I'll use a transform node here, put this in here. And then you can see immediately what a trail will do. So the moment I start moving this, you see that trail actually leaves the old value there. So that's what I wanted to show you. And what I will do is I will use these values that you hear to move the eye up and down. So like this, from -1 to 1. And then the translate y will go automatically using this ping-pong effect. So let's do translate y first. Let's edit the expression. Again, it's an OSC value receiving on this node channel with a default of 64. But again, this is going to be a way too big of a value. So we will transform this using a map. Again, from 64 to 76 and from -1 to 1. Now we see that the eye is actually visible. And now if you press run, the eye sort of jumps up and down, which you can see here. And for the X parameter, what we're going to do is use ping-pong with a value of -1 to 1, maybe -1.5 to 1.5, with a period that's quite slow, like 10, for example. And now it sort of moves from one side to the other. Maybe -1 would be enough, I guess, because we're cropping part of this as well. All right, and now let's run it and see what the result looks like. As you can see, there's a lot of things that you can experiment with, and it's really easy to get started and just put expressions anywhere and use them as your nodes. So I encourage you to try things out, experiment, connect it to any application that supports OSC, and see what comes out of there. Thanks. See you in the next one.